Hello everybody, welcome to my YouTube channel. I am Krishna Gopal. In this video I am going to discuss the most important question from the regularization which interviewer can ask you in the interview. This question I face many times, but in many cases I face the follow-up question also. So the most important question is that what is a difference between the L1 and L2 regularization? You know, the regularization is one of the important concept in the machine learning, but what is a difference? Because L1 and L2 are the two terms which are the types of the regularization. So what is the difference between them? So question is what is the difference between L2 and L1 regularization? L2 regulation is known as the rigid regression, whereas L1 regulation is known as the lasso regression. L2 regulation add the square term in the cost function to prevent the overfitting. Let us suppose we have the C is a cost function, so it add the square term in the cost function, whereas L1 regularization add the absolute term in the cost function to prevent the overfitting in the model. L1 regularization can use as a future selection. In one of my previous question I tell L1 is used as a future selection. If you not pause that video, go and pause that video. L1 regularization is used as a future selection technique, whereas L2 regularization is not used as a future selection technique. So this is the very basic. What is the difference between L1 and L2 regularization? This is very basic and most of the people know the answer. But the thing is that how L1 regulation create the sparsity. As I told, we use L1 regulation as a future selection technique because it can create the sparsity as it transform the useless feature to the zero. But many times I face the question, why the L1 regularization create the sparsity? So this is the most important question. So let me explain you how it can create. So as we know, L1 regularization add the absolute term to the cost function. So suppose C is a cost function and it add the absolute term. Now if you notice, this absolute is not differentiable at only 0. Rest of the other points it is a differentiable. So if I do the differentiable del L1 by del W, it's come C plus lambda W, C plus lambda if W greater than 0, and it comes C minus lambda if W less than 0. At 0 this function is not differentiable. Now if we use the gradient descent, we remember the equation W nu is equal to W minus neta del L by del W. Okay, so for simplicity consider neta is 1. Now if you put this equation here, W nu W minus C plus lambda C minus lambda W greater than 0 W less than 0. Okay, so these are the equation. If you see the W is greater than 0, if you come to this case, in this case what lambda is doing, lambda tries to make the less positive W, and if you see the lambda is greater, if lambda is less than 0, then in this case lambda is tried to make it less negative. So what the overall thing is happening is that the W in both the situation approaches to 0. As in the first case, this lambda makes them less positive, and in the second case the lambda make them less negative when W is less than 0, and in the first case when W is greater than 0. So according to the both of the cases, what is happening, W is approach to 0, and that's the reason how L1 create the sparsity. Now why L2 not create the sparsity is that because when you write this equation and W nu is equal to W minus that's come 2 lambda W, I think, yes, 2 lambda, yes, 2 lambda W. Now if you see this one, this function is a first differentiable throughout, and in the case of the L2 regularization it is a linearly decreasing, it also approaches to 0, but not as much fast as compared to the L1. That's the reason L2 is not create, L2 can't create the sparsity, whereas L1 create the sparsity. So these are the one follow-up question which can come from the L1 and L2 regulation difference. So that's all for this video. If you like this video, then please like the video, and if you have any question, then let me know in the comment section, and hope we'll meet you soon in the next video. Thank you.